Okay, so a few semesters ago, probably about a third of the way through the semester, and it wasn't in D4, it was actually in D5, which is identical to this, I believe. And I was standing here, and a student came up to me, and they said, "Hey, professor, you know what exploding chickens is?" And I said, "No, I don't think I do." And they went on to explain to me that they had this personal project. Now, I'm sure most of you here in CS, you've been told, or maybe you know already, right? Doing your own personal projects to display kind of skills and stuff beyond the classroom, these are things you can use to show in interviews, right? Interviews for internships, interviews for job. It's a way to expand your skill set beyond the classroom. And this student said, "Well, I kind of have some questions about it. It kind of works, but it's kind of a mess, and I was wondering if you could take a look at it." So I did, and we kind of went back and forth, and this student and a group of other students, they continued to work on it. And then just recently, that same student reached out to me and said, "Hey, professor, you remember exploding chickens?" And I said, I do remember it." And they said, "Well, it's completed." And we actually wound up going through several stages of development, and I think I really want to present not just what it is that I did, but how I did it, what I learned from it, and how it kind of applies to the classes that I've been taking. And I was wondering if you would take a look at it, and we could talk about it, and maybe I could talk to your class about it. So literally just yesterday, we played some email tag, and just yesterday we finally got together, and I kind of took a look at what the student wanted to do and wanted to talk about, and I said, "You know what? This sounds exactly like what most CS students in the 10 years I've been here have either done, started to do, talked about doing. I think it's a great idea. And I think it's a great idea just for that student to get up in front of people and give a presentation and talk about it. And it kind of fits in with what we did this week, right? We took a break from Java, we took a break from threading and all that. I talked about some of the stuff that I've done in my labs. I thought it would be nice to have a presentation from one of your own colleagues who did a pretty cool thing. Does that sound all right? All right. The person presenting gave a thumbs down. It's too late. We've locked the doors. You cannot escape. You have to do it. That student, Radisson Ackerman, how many people know Radisson? Okay, Radisson has a fan club here. For those of you at home, you can't see it. So what I'm going to do is I actually have the Echo live stream up on my laptop. Those of you live streaming, if you want to ask questions, post them there, and then I can stop Ackerman as he's talking and ask him the questions for you. Other than that, without further ado, I want to introduce you, those of you who know him and those of you who don't. Radisson Ackerman's going to talk about Exploding Chickens, a full stack card game. Addison, come on up.
All right, this guy's gonna...
Now you're going to have to figure out how you want to fasten this guy.
Okay.
So I'll hand him off to you. I'll be over here.
Beautiful.
Stage yours.
All right, let me get this figured out. All right, cool. So first off, I want to thank Professor Hallenbeck for giving me this opportunity and allowing me to present in front of you guys. It means a lot to me, and I think you guys will benefit a lot from it. But as he said, today we're going to do something a bit different. And we're going to talk about like a card game or a full stack web application that I made. And then we ran into some bumps in the beginning, and we're still running into bumps now. But I know a lot of you really want to work on your own personal projects and make something that's big and something that has a huge code base, much bigger than what we could do here in class or what we have time to. So yeah, let's get into it. So first off, I'm Radisson. I'm a CS major along with most of you here. I'm also a business minor here at UIC, and this is my second year at UIC. it might sound odd that I'm a second year and I'm standing here in front of you guys, but I'm kind of blasting through classes, so things went a bit faster. I have a pretty rigorous schedule, so it's been that way. Regardless, I also moved in more of a project manager role here at UIC for the College of Engineering. So in that capacity, I used to be a web and database developer, and I kind of still am. And I think one of the developers is in this class somewhere. But I'm kind of like project managing about 7 web developers, and we're getting through projects on a large scale, similar to what Exploding Chickens kind of is. So we're building web applications for the university to try to get away from like building like a paper method. So normally in the university, it's like you have some piece of paper, like you want to buy something. And then you have to give it to your admin, and then it has to like go down this whole chain. Essentially what we're doing is just making web applications off of that to help streamline the university. So it's all in-house, and I'm helping manage those projects. Another thing that I'm also doing is I'm also a web security intern at the U.S. Department of Veteran Affairs. In that capacity, I'm more working on kind of like cybersecurity stuff, because that's what I'm looking to get into down the road. Is I deeply love web development. I've been doing it since like 8th grade, but I really want to get into the cybersecurity leadership space. So that opportunity is letting me get there too. Besides eat, drink, and sleep in computer science, I also really enjoy doing photography, as well as cycling and swimming. I'm looking to do the Chicago Triathlon this summer, and I don't like running that much, so we'll see how that goes. But I'm hoping to put those two together to do that. Other random things is woodworking, chess, and small electronics. So enough about me. Let's get to explaining the game a little bit. So Exploding Chickens first started out as an idea that we saw the Exploding Kittens card game, if you've ever heard of that. And we wanted to play at our lunch table in high school. So instead of buying the game, we just decided to essentially design cards that look almost identical to the ones that are in production on the actual game. We printed those out, we cut them, and then we played the game at our lunch table physically. But as COVID happened and we were all going to college, that opportunity for us to play that game kind of vanished. And the only other options were like some kind of like subpar like online card games, and there's like COVIDopoly, which came out, which the creator of that actually came from my high school, and I don't know him at all, and I didn't realize I knew him until way after finishing this game. So how the game works is there's just a discard deck and a draw deck. The discard deck has a bunch of cards in it. They're dealt out to players, and then you essentially play certain action cards during your turn, and then at the end you draw a card. If you draw the Exploding Chicken, you have to use a diffuse card to stop yourself from exploding. If you explode, you're out of the game, and your goal is to be the last one standing. So at first the discard deck is 0, and the draw deck is 52. It's dealt out 5 each to each player. And then, again, the Exploding Chicken, on the website, this is what it looks like. So it says, avoid this guy at all costs. If you get it, you're dead, and you can't defuse it, you're dead. So there's a super nice, clean description. But in more terms of a CS perspective, this is kind of what that logic is going to look like. So if we draw that card, there's kind of some things that happen there. So, and it gets very complicated, and that's kind of the point that I'm trying to get into, is if we draw that card, we check if they have a diffuse. If they do, we're going to play that, the player should play that diffuse unless they don't want to and explode. And they place that card back in the draw deck. If they don't have a diffuse, then they explode and they're removed from the game permanently. One thing I want to mention now is, as I'm going through this, please ask me any questions if it's unclear. I'm going to dump a lot of information on you guys, and for some of you, it may be completely brand new, and it may not make sense, but for others, I'm kind of targeting like more of a CS perspective, so you'll see kind of these if-else statements here, so I can explain it simply. So does anyone have any questions? I'm going to keep going and explain the game, but does anyone have any questions on how the base setup or what that looks like? All right. So again, the diffuse card. If the player draws that card, it will be placed back where am I going? If they draw that card normally, so they draw it out of the draw deck during their turn, then it's just placed in the player's hand. That's really all that happens. But there's more of a kind of like where it gets more complicated, is if this card is played and the player is exploding, so they have to be exploding and they're trying to play it, then discard the card, prompt them to put the chicken card back in the deck, and then advance their turn on to the next person. So that's kind of what that workflow looks like for that card. So what I'm trying to show here is when we play a game within ourselves in like an in-person format, it's very easy to pick up on the rules and figure out what we can do and what we can't. But trying to explain that to a computer, although it looks pretty simple here, making a framework to be able to, like, for a computer to be able to understand that is actually more difficult than you anticipate, and it's what I ran into in version 1, but we'll see here. So the shuffle card, and this is kind of the card that we're going to use throughout this presentation of explaining it, is it's pretty simple. It's a traditional shuffle card. So if the card's drawn, put it in their hand, kind of like the diffuse card. If the card's played, shuffle the entire draw deck and discard the card, so it's not in the player's hand no more. So it's pretty simple on the surface, but if we look at it in terms of a framework and a CS perspective, it gets complicated really quickly. So first we have to check, okay, first we have to know the player wants to play this card. Somehow we have to know that. So in 342, we're learning about event-driven programming and kind of how those concepts relay into making a game like this. So we have to capture or see some event that the player wants to play this. So we send on the front end and the back end, I'll explain this later, but that player sends some play card event that we want to do this. Then on the, then the computer has to figure out, there's this like cascading validation phase, so kind of what I talked about earlier, where is this player valid in the first place? Is it their turn? Do they have this card? Like somehow did they try to play someone else's card? And can they even play it now? So if they're exploding, they can't play something like this because they can only play diffuse cards. So there's a lot of catches there. Then finally, once we get through this validation, it completes the card action, which is shuffling the draw deck. And then it discards the card. And then at the end, we have to wrap up and tell everybody what happened. So that could either be an error, or they actually completed it, or something else. There's a lot of edge cases there. But that's the shuffle card, and that's just one card of many that we made. So each of these cards and their graphics are kind of odd, but they work. This is like kind of what we had on the initial version. So they work, but there's a lot of card actions. A lot of stuff you have to consider with multiple edge cases and multiple situations where they could be played. So the first 2 rows, those are like the traditional base deck. And what you could play in part of the base deck. The last row is the new Yolking Around expansion pack that we released. And those guys are all card actions that we made up. So the first part was kind of, we're copying Exploding Kittens. The second part is we're kind of delving into our own territory and thinking of new things for the game. So with that, we first released this a year ago. So the development process started and it was winter break of 2020. And I thought personally, I was going to be with my friends, we were going to finish this project over winter break, call it a day, release version 1, and not really be done with it, but have a workable version that everyone could see. It ended up taking until April to actually get anything done. So it was a massive, I don't know, we just massively underestimated the amount of work a game like this would take, primarily because there's all of these like validation phases, and there's a lot more logic that you would not think of. I don't want to try to intimidate you with a big project like this, but the point is, it's a lot of work up front and it took us a long time. But through last April, we've had, I think it's at 580 games played now, but 565 games played, over 4,725 minutes of total gameplay, and there's been, people have clicked that draw card or play card button over 20,000 times. So this is actually just the start, and we haven't attempted at all to market this. But we're hoping through the release of version 2, we can kind of push this to more people and explain, hopefully get our game to the masses to some degree. So, all right, let's step back again to the beginning of where we started at this. So you're kind of asking yourself, once I had the idea, I'm like, okay, I want to play this with my friends. I want to play it online, but there's no options available. So you're kind of like, where do you start to make something like this? Do you use Java? Do you use JavaScript? Do you use, there's a plethora of possibilities to make a card game like this. And I can guarantee you there's probably some platform that would work better for our use case which I'll get to in a second, but there's definitely better options than what we chose just because we didn't do enough research. So things I wanted to target when I was making this is we want room for expansion, so we want to be able to like make this something better. We don't want to make it once and then it's kind of stuck where it's at. So there's that, something that's scalable and fast. So if this does explode, then we want to be able to like, kind of like do load balancing, kind of more like complicated web stuff. So we want to make sure it's scalable, so if all of a sudden 1,000 people are on it tomorrow, we can handle that. So we want something that's fast too. We also want something that's quick to develop. I think everyone would want that for any personal project, so you don't take forever. And then there's like rendering, and once you get into the depths of web development, it gets more complicated than just the HTML page. So there's things you want there. You want something that's easy to play and something that maximizes compatibility. So at first you're like, why don't you make an app? For me, I didn't want to make an app on the App Store or something, is because Exploding Kittens already had an app that you had to pay like $5 for. So like, we would be like directly competing with them, and I didn't really want to do that. And I thought a web application runs on anything, runs on your computers, your phones, anywhere. So that, at least in terms of a development, like where we wanted to go, we knew we wanted it to be a web application. So with that, I did some research, and since I've been doing this for a while, I kind of chose on a biased sense of what tools that I wanted to use. So I immediately went to Nodejs, which is more of like it's a more complicated JavaScript on the side of networking. So Nodejs is almost made to work with like web applications. So there's some issues with it, but it's fast. There's a lot of applications, like a lot of people use Node.js as far as like a JavaScript side goes. If you want to do a Java one, there's Spring Boot. If you wanted to go the Python route, there's Django. There's different frameworks you can use to help scale your, make your development a bit faster. So yeah, Node.js is an asynchronous event-driven JavaScript runtime. Essentially what that means is we can tell it to do stuff asynchronously, so all at the same time, and we can also tell it to do things sequentially in order, which is doing things sequentially and in order is incredibly important for something like this, because you don't want them trying to play the card and then say like there's a discard one. You don't want it to discard the card while they're still validating or something like that. So you want to make sure it does stuff in order. So that's having something that does stuff in order, like as a default, is important. We also need a database. You could use classes and build your own data structure that would run as the application runs. But that kind of could be an issue, because if I decide to restart or push new changes, all that data is going to be lost. So we want some permanent database like SQL or NoSQL, which is MongoDB, that handles that. Essentially what, we'll get to it in a second. And then the two other things that we picked were handlebars. It's basically just HTML, which is what what your browser uses to read anything. We chose in the beginning not to use something like Vue or React, if you're familiar with those terms. They're newer, kind of like web development frameworks on the front end, so what your browser sees. But I wasn't experienced in it, and we kind of just wanted to get it out there. So I just wrote everything in pure HTML and CSS, which is a lot more work, but it allows a lot more like fine-grained control. But with version 2, we're starting to feel those pains, I guess, of choosing this up front. We also chose Socket.io. This is essentially WebSockets, or just sockets for the internet. WebSockets are already on the internet, but it allows us to tap into that, getting bidirectional real-time communication between the server and the client. So the client's running it, the server is the thing that's actually making all the decisions. So we have real-time communication between both of those. In layman's terms, what that allows us to do is you don't have to refresh the page every time anything happens. So that's what the power of that is. So this framework that we chose is also very applicable to 342, is the MVC model. So what that means is you have a model, which is a database, so some database that's going to store data. Then you have a controller. That controller kind of makes all the decisions. It's the one that essentially holds all the code, and that's where you write everything. So the back end as a unit is supposed to be very smart and it handles everything. The front end, on the other hand, which is using Express as an engine out of Node.js, it's supposed to be kind of dumb. It's not really supposed to know how to, it doesn't really make any decisions. All its job is to receive some data in a payload and then show that data on your browser. So that's its only job. It's not meant to decide if they can play this card or not. It just, if I say play this card, it's going to send it, and it's not really going to check. So there's these two parts, the front end and the back end, and these two are really important into making something like this. So you can see there's also those dots there that are the intermediaries. So Node.js can't directly communicate with the database. So it needs something like Mongoose, which is ODM, that allows us to talk between the two. Essentially, that's all it does. It provides us an interface to talk with our database. And then we have Handlebars, which is that templating engine I was talking about, as well as Socket.io to kind of bridge that gap between the front end and the back end. So right, for version 1, this is what the schema looks like, or what the data structure looks like. So with MongoDB, it's a NoSQL format, and what that means is that all the documents, you have documents, and within those documents you can have any data. So on a super high level, you have a game as a document, and that game technically could contain any data that you want. It doesn't have to be cards, players, and events every time. It technically could be something else. So the reason why we chose something like a NoSQL alternative was that if we chose to modify the data structure later, it would be stupid simple, and it really wouldn't impact the rest of the platform. So essentially, all that is just you have documents within documents. So the cards, players, and events, those are called subdocuments. So the game is the root level document, and then you have any number of cards as an array, any number of players as an array, and any number of events. So in a card, like this is kind of how we chose to, and it's not perfect, but this is how we chose to represent the game in a data format. So we have the 52 cards. They all have a unique ID. They have actions, so what does that card do? The reason that it has this action parameter is because in the game there's 6 diffuse cards, so the ID is diffuse-1, diffuse-2, but that action is just going to be diffuse. So we can identify, it might have this pretty ID, but we can clearly say this is diffuse card and we know what to do with it, so there's no playing around there. There's also an assignment. What that means, and I think it's pretty smart, but there's this assignment parameter, and there's multiple assignments or places that the card could be assigned within the game. It could be the discard deck, it could be the draw deck. And if it's not either of those two, we assume it's in a player hand. So the assignment would be updated to the player ID, which is another list of documents. So if it's not the draw deck or the discard deck, or technically it could be out of play, which is also a parameter, it's assumed that it's in a player's hand, and that card ID will match the top of the ID on the player's end. So it makes it so it's pretty clean, and you don't have cards being moved around. So if we had one discard deck, we'd keep moving it around, and it would just get really messy. There's also where is it located within that, wherever it's assigned, where is it located? That's where it also gets tricky, because you have 52 cards, 0 through 51. That global position in terms of document structure is not representative at all of where it's actually located within the discard deck or the draw deck. So we need something there to identify that. There's also what pack is a part of. And then on the other hand, for the player, in the events, it's something similar. The players are the people that are playing the game. And then the events is anything that happened during that game. So if, for debugging purposes, we could go back and say, okay, or if someone complains and this part of the game broke, we can say, okay, here's this event log, and then we can try to figure out what happened. One thing you'll learn if you get into web development or anywhere is you want to store everything. Anything that happens, you want to keep it, just so that you can go back and figure out what happened later, or save analytics or something of that nature. But we're not saving anything sensitive. So we just want to keep track of stuff that's happening. There's this request player and target player and blah, 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 related key value pairs. Those just essentially apply to anything, and based on what event we're logging, it uses those parameters as it goes through. And there's also miscellaneous game data, but right. So now I just want to go back to that shuffle card example and what that kind of looks like within Exploding Chickens. So if I'm on the client end, so that's the front end, it's at the top, it has that real-time bidirectional communication. So it goes first to, and these are like literal files within our project as of version 1. So it goes to a socket handler. The socket handler decides, hey, I want you, say we're trying to play the shuffle card. It says, okay, I see you're trying to play a card. And it says, okay, I see you're trying to play a shuffle card. And then that shuffle card, it just keeps cascading down into game actions. The game actions figure out, okay, you're trying to play a shuffle card, goes on the card actions, and then it finally actually shuffles the card, or actually modifies our database in order to represent that change. So it gets complicated, but this is where we made, or at least I made, a fatal mistake when designing version 1. Is this tiered approach makes total sense, and it's how it is in version 2, but there's a ton of overlap between these three. They should be distinct parts. There's a ton of overlap between all of them. So this, in the socket handler, you can't read it, but this is the size of the socket handler just for the play card event handler. So if I try to play a card at all, it's like 200 lines to figure out, for that system to figure out what's going on. So I don't think we'll be able to, you kind of can. Not really, but on a super, it wasn't really meant for you to read this anyway, but you can if you want. But what it's meant to illustrate is, it's doing this thing called callback hell, which is where you have a ton of nested if statements. And at first when you're developing something, that's fine, but the reason, it looks nasty. It keeps going in, and it's really long. And a lot of things are being repeated. So like for the middle one here, it says the trigger is see the future. So if I try to play the see the future card, it's going to log something, which is fine. But then it tries to find the card, log the event, update the game UI, and then send another thing also to the client. So what it's doing there is for everything that happens that the client needs to know about, in the socket handler itself, is trying to figure out what to tell the client to do, which when you're first diving into it and not really thinking about it too much, that makes sense. But as you add more cards and more cards and more cards, it gets kind of nasty, and that was a pitfall. This is the other pitfall, is even bigger function. This is in that game actions. So what's supposed to happen is you have the socket handler, it sees that you're trying to play a card. Then it goes to the game actions and says, okay, play this card. So same thing, it's complete disastrous. It has it has an else if statement for every card that you could play. So on the other slide where I show you all the cards, it has a if statement for every action. That's not good. So this has a router, or I call it the base router. So it's essentially routing card actions to what it actually does. This is a way to do it, and this version works fully, but it's not clean at all, and it's really hard to see. So in version 2, we decided to take in a segmented approach and not really throw out everything we had, but redesign everything we had and implement a new data abstraction along the way. So we kept everything as is, but we decided to put this new lobby abstraction on top of everything. Essentially what that means is you can have one lobby, and then within that are games. I'll show the abstraction on the next slide, but it allows, I could have 100 players in a lobby, and they could automatically be allocated into their, whatever games they want. So a big kind of complaint we got about version 1 is if I have, if you're playing some of the more popular competitive games, it's you only can have 5 players in a lobby, or 5 players in a game. So we kind of wanted to get rid of that issue by making lobbies so that we could have 100 people join a lobby and then put them into their respective games and have them play that way. But this also meant throwing out a lot of throwing out a lot of what we already did, because throughout the entire thing, the game was designed to be the top level thing. So we would search for a game and then do everything from there. But now we're searching by a lobby, and the lobby has to do everything. So that actually broke literally everything, because it was always looking for the game first when it should have now be looking for the lobby first. So we stuck with the same web stack, but I just did this really sneaky thing last night, which I didn't know you could do. But I have it running handlebars on HTML, and I also have it running Vue for some so for some newer pages, we're using Vue, which is a lot cleaner and faster. But I didn't know you could use them both at the same time, which is something you definitely should not do. We should have used Vue from the beginning and then built it that way, but I didn't know how to use it at the time. We're also using Auth0 as an authentication service for players to be able to log in. And then another big part of this was test coverage. In version 1, there was 0 test coverage. There's nothing. But in version 2, we're like, hey, we're rebuilding everything. Why not write test cases for all the stuff we're writing, so that we have full test coverage that proves that our platform, so to say, is ready to go, and we know there's not going to be any bugs with it, or at least to some degree. That's a problem with JavaScript. Is that with JavaScript and Java, they're all runtime. So as you're running them, it will see those errors as they occur. So one thing that would happen, like, say there's a small bug with one of the cards that we had, we would never actually discover that bug until that particular card was played. So we would never, like, once we compile and run it, JavaScript doesn't care. It's just going to run as it goes. But say it's a catastrophic error at this particular card action, then it would break. And we wouldn't know that unless we tested literally everything on the site. So, and Python does the same way, but if in 341 you'll learn that like something like F#, it compiles everything. And then it checks for all those errors up front. This will only run into errors when we run into them. So we wanted to write test coverage for that. That ended up taking 3 months alone to write test coverage for the complete project. We weren't even making any new features, just testing everything. So it's a pain. It's really a pain, but it's worth it to make sure your platform, whatever your project is, works well. We also moved into more of a project managed type scope. So instead of me just making everything and everyone pushing to one branch, we chose a new model where issues are logged. Those issues are logged, or it's an issue and an enhancement. We choose if one of the team members wants to pick that up, then they can go ahead and solve, kind of fix it or make it on their own branch. So that's a much cleaner way rather than everyone pushing stuff to one branch. Again, issues tracking and lobby abstraction. But yeah, so this is what Exploding Chickens turned into on GitHub. You can't read that, but this is basically the issues page. We have a bunch of issues that were completed, but I'll read off the top couple. There's like one time I noticed that the game redirects for the new abstraction were unclear, so I logged that. There's a bunch of details there about what that looks like. Actually, it's okay. But there's just a bunch of them there. Anytime I see something, you make an issue. If I want to rework something, like even in the beginning when we wanted to rework everything, that was made as issue. So that's what that looked like. So I guess for big projects, it's super important to have even if it's your own personal project and you only see it, I think this is incredibly important to have something like this, just so you can organize how you want to build it yourself. So like say in the beginning, very beginning, I could have just made an issue saying, get the game schema working. And then say I also wanted to say, okay, set up a framework for like the play card action or whatever to work. I can make all those issues up front. It's not the cleanest way to do it, but you can make all those issues up front and then just go at it one at a time, segmented that way. So that's what we did. And it allows us to work a lot better as a team. So version 2 changed in this sense where there's the main lobby abstraction, but now there's games, and those games have card and events similar to how they had before. But there's also, the players are separated from the game, which may seem odd at first because you think like a player is always in a game and they're playing that game. But the problem is all this player data, we didn't want to keep copying it between. There's this really nice partition players function in the lobby abstraction that says, okay, whenever I'm run, I'm going to look at all of the players and I'm going to look at all the games, and I'm basically going to handpick players and put them in a game. So essentially what that means is before the games start being played, any of those games are volatile. Like they could disappear at any time. So what we wanted to do is say, we don't want the player data within that. So, you know, what we did is the games are completely separate. They could just disappear at any point, and the system would be fine. But it has this new game assign parameter that you know, routes or points directly to the game. So that way, you can look through the player. There's all this data on them, and then go back to the game. It also works the opposite way. So if I'm in a game and I want to know who's playing right now, I can, like in that game, I can just say, okay, give me all the players that are actually in this game. And then it'll give me an array of this, of all those like 5 players. And then I can say, okay, this is their seat position, and then all this other stuff. Same thing with the events data structure. I can almost guarantee it's not a perfect approach, but it works better and it's more clean. So again, you might not be able to see this, but there was that play card socket handler that was 200 some lines. Now it's just over 30, I think. So it's this whole block right here. And it's doing this really clean asynchronous waterfall kind of like methodology. What that means is it comes in and then it does all these pre-checks up front. So it's essentially running functions one at a time. If those functions fail, it'll immediately like escape. It's kind of like a try-catch. So if it fails, it'll immediately escape and then notify the client that, like, so say the first one, it says waterfall dash or underscore get or game underscore get. So at first it's just going to get the game of like wherever they're trying to play the card. If that game doesn't exist, it's going to kick them out of the waterfall and nothing else is going to happen. So it just keeps going down, and what used to be 100 lines is now just 4. So you know, it gets the game, it validates the game, it validates their turn, and it validates that they're not like, there's certain locks that you have to do. I could get into this, but there's like delays and stuff, so you have to like make sure they only play this card once. That's essentially what that does. But then once we're done with that, we get into the actual function, and it only calls that play card function once with all the data that it needs. And then it gives us this really nice callback object, and that callback object can be sent directly to the client, and the client knows what to do with that. So we're essentially just sending that callback, it's just an array of data, back to the client, and then it knows what to do. So it's super clean, and super, it makes a lot of sense, a lot more sense than the other version. And then there's that base router that was also bigger. It's still big because you need to look at every card action. But before, for like, say I'm trying to play an attack card, it used to be 8 lines just for that one attack card. Because it would have to go through and try to do everything that it would do for that attack card. Now it's just 1 line. So it just runs that card action, and then it returns by reference that callback object. And then that callback object is just basically sent directly back to the client, and the client knows what to do with it. This is super nice because now we don't have any mixing between the front end and the back end. It's expecting this callback back on the client. And it's, you know, like if we want to run test cases on it, it works fine because we can just look at that callback and see what happened. So for test cases wise, it works well. But yeah, there's a couple, I mean, this is near the end. If you guys want, we can look at certain stuff, but certain stuff in the code. But the main points I was trying to get across is if you want to do something that you think could be big, even if it's small up front and you think it could be big, make sure you do a lot of research into what frameworks and platforms are available to you as you're picking that language or framework. So that stuff is super important because I really wish we would have used Vue in the beginning, but we ended up using pure HTML. So it would take like another 100 hours, just because we chose handlebars up front, it would take another 100 hours to try to implement Vue. So it would just take as much time. Make sure your data structure is pretty solid, because that was another issue with version 1, is the data structure was good but not perfect. There's a lot of redundancies, which are good but also annoying. And make sure there's good boundaries. I know in all the classes they're really pushing this, which is good. But make sure everything is separated and you can actually test everything. Because we had so much mixing between the socket, because the socket handler was only meant to be client-facing. So there was so much mixing there that it was just very difficult to test anything because it was dependent on some front-end feature. So Yeah, and then also make sure you give your room something to build, give yourself room. And make sure you visualize everything. So writing things down on a piece of paper, that'd be a great way to go at it. But yeah, I don't know if you guys have any questions up front. If not, if you guys have any questions, I can look into anything. You right there.
Yeah, so I wanted to ask about so first of all, how many people were working on this project?
Yeah, so the question is how many people are working on it? For the most part, I would say I personally did about 80% of the work because I had a relentless drive to finish it and get it done because I was so invested in it. But there's probably about 5 other contributors on the project. So like I didn't design the cards. That was my friend Singdao at Northwestern that designed them from high school or whatever. So yeah, there's a lot of hands in there. And if you guys are interested after class, there's still room. There's like version 2 hasn't come out yet. There's a lot of room there. So if you're interested, there's that. You had another one after that?
So I'm not sure how much of an issue that this came up for you, but when I've ever tried like doing like collaborations with like on code with other people, one of the issues I always like found was that like sometimes code just relies on other code to work, and so when when 2 people working on something, it's really hard to like really get it done because you have to rely on someone else to do it, but if someone else is doing it, you can't really work on it at the same time. And I want to ask, like, did this issue ever come up for you, and like, how did you get around that?
Yeah, totally. So the question is like, how do you work with other collaborators, I guess, on something that needs to get done kind of quickly? And it might be like other people have different commitments to other stuff, which is fine. So they might not be able to put as much work in. But we ran into this issue a ton. I mean, it wasn't to anyone's fault that was working on it, but for the test cases, that was a bit tricky because certain test cases were reliant on other people finishing other test cases. So because we wanted to have this whole like system of how they worked. So I had some people, I'm like, okay, you can do this part of it, you can do that part of it. But it's essentially what we had to do there is, and what I've learned is make sure you divide it up into small tasks. So that like instead of giving someone a huge chunk, which I often did, make sure you give them make sure there's like smaller, very easy to see tasks that can be done. And if other people can't pick it up, then someone else can jump in and kind of pick up where they left off. If you give them like a huge mini project, it may be hard if they don't have the time commitment. Yeah, I hope that answers that. Anyone else?
Can you play the game?
Yeah. Yeah, we can do that. I think what might be a little bit more useful is if I show you. Yeah, I can't do this on the iPad. I'm going to have to show you on here. But what I think might be useful is if I show you guys the code and kind of what it looks like right now. I could show you guys version 1 too, but let's see. Is there any other questions on the framework side before we get into that? Yeah.
Like how much diagramming and drawing out, and you have to do more or less?
Yeah, that's totally something. That was the thing is version 1, it was just all in my head, which is a huge mistake. It was all in my head, and I just typed away at the computer what was in my head. So in version 1, there wasn't really any diagramming because it was just all an idea. What I really should have done is, write down some diagramming and figure out how I wanted things to work together. I believe it sometimes, have just like a napkin to write stuff on to figure out how to do it. But But for version 2, there was kind of some more diagramming, but we didn't put too much of an emphasis on it because the framework was already there. So majority of the diagramming wasn't done. So we didn't have a huge reason to do that, but for the project I worked on for UIC, there's definitely a ton of diagramming. So there actually is some, it's not diagramming in traditional sense, it's called a user flow document. So if it defines literally everything a user could do on the site. So it says at the home page, the only thing they can really do there is click to play a game or join a new game. It defines everything that could happen in that home page. And then the lobby page, it says, okay, this is everything that could happen. Those are pretty useful. And it's kind of more of a thing we did after the fact, but it helps someone clearly understand where all the edges are and what you can and cannot do within the platform. But it's a really long document. It's 10 pages because it defines literally everything that could happen. So Right. So, any other questions? Yeah.
So I'm just curious about like, were there any like specific issues that like you guys came across in development that like it was just like really big errors and you just could not figure out how to get past like, and you were stuck on this for like a really long time?
Yeah.
Or like any like specific issues with it that you know?
Yeah, one thing that came up a lot was the whole idea of how we were gonna target this favor card, and with this favor card, and it made it more complicated because what the favor card does is it, well, this is the wrong site. What the favor card does is like, so say I play it during the game and I target you. If I play that card, it will steal a card randomly from you. But it's more complicated in the UI aspect because I have to notify you that a card was taken, because it might just disappear. Like if you don't put that in, it'll just disappear. So that was, and it like, there's a lot of issues there, and something that we still haven't implemented, which is there's supposed, for one of the cards, for the favor card, it's supposed to allow that other player to pick what card they want to get rid of. So that's it's a lot of work because you have to know that that player is trying to play that favor card, and you have to simultaneously ask that other player to give up a card within a certain time limit. So that's kind of an issue that could show up. So, and then also the exploding chicken, like if you draw the exploding chicken, that was also insanely complicated because once you draw the exploding chicken, it has to like, you can't just wait forever. Like you have to say within 10 seconds they have to play it. So at first we tried an approach where all together, like so say you have 4 players playing, those 4 players were responsible with figuring out like if that player was going to like time out. Like so if they didn't play within 10 seconds, it together was going to try to figure that out. But that's super unreliable because what if everyone leaves? Or what if the person trying to play that card leaves? So that led to a lot of issues, but now it's all server side handled. So the server just counts down, tells everyone else what's going on and then how to play the card. So that's, that was tricky as well. I don't know if this guy's working. I may have to restart this. I hope that answered it. Is there anything else?
I have a question.
Yeah.
So for something like as big as this project, and at the same time you manage coursework for the school, and then also like another job as well, where did you have time to do this? Because I know you said you did like about 80% of it, so most of it was on you.
Yeah, it would kind of just like, whenever I had time for it, it would kind of just fit in. So like if I finished, like schoolwork comes first, and then after that it was just, if I have time to do it, then we can. But I would say like during peak development, I was putting at least 16 hours a week in, which is a ton, like relative to school and everything else I had going on, that was like a ton of work. But that's what it took to get it done. So yeah, I don't know how I time managed, but yeah, it was tough. It was tough. It was not easy. But this is really, it's much bigger than I anticipated too. There we go. Beautiful. But yeah, I have a Ubuntu on this, and I'm not recommending you use it, but it's just really nice for web development, and like this or a Mac. I had a Mac before, and then I got this. So it's just really nice for web development because you just install all the packages up front. Okay, that's not the right one. This is a different site. Okay, so this is the most recent and active development branch. I don't know if you guys can see any of that. It's kind of small. But anyways, even now, like just in terms of a scope, all of that on the left side, like that's how many files and directories there are, and all the directories are collapsed except one. But there's a lot of stuff going on there, and at first it was just a couple directories, but now you have configuration, coverage, documentation, handlebars, which is all the handlebar pages. There's the models, which is all the schemas. There's node modules, so that's basically all the directories. There's packs, so it's just a static array of packs for each one. There's public facing, like so CSS and that kind of stuff, like images that anyone can request. There's routes, so if someone comes to the application, where do they go? There's services. That's actually the whole game engine, if you will. And then there's also a huge test folder, and then there's the view stuff that I was working on, and all kinds of other stuff. So it gets really big really fast, but normally it would just be something like you'd have a views folder, which contains all of your, like all the pages you have on the page. You'd have a routes folder, which is where you want all the applications to go. And then you'd also have some type of, if you have models, you could have that for like your database schemas. And the last one would be the, like services or something that actually runs your project. So, and then you'd have like one entry Node.js or like app.js file, which is where the application would start. So normally this would be separate too. That's the other thing. The front end would run on its own instance, and then the back end would run on another instance. I chose to put them together just so that it could be easy for me to run. Like in the beginning, it's super easy to get it all running on one thing. But as it gets more complicated, you want those to be separate. So there's a lot of work here, and it's, I mean, I guess if I just do npm, so like there's this test command, and you probably can't see it, but it's going to run so much stuff. And then right at the bottom where it's lagging, we made this game simulator, and it runs through 6 lobbies with, I think, 2 to 17 players, and it plays like a stupid amount of games within itself. So it played 54 games with itself over 4,000 card interactions. So things are happening. But I could say, play one game. Like I made this really nice test case that it literally exhaustively runs through everything, and it plays a game with itself. It's just randomly playing. It doesn't have AI or anything. We're planning to do that eventually. But it's just, I could say play 1,000 games with yourself, and it would go ahead and do it. And then that's kind of like something you kind of have to do with something like JavaScript, is you have to see where, you want to see where all the edges are. So if you run through every possible combination of the game, then hopefully you run into one of those edges. So, but that took forever. Like what we were trying to get to is this nice table at the bottom, which is all green. Pretty much that says every file except the front end in our code is completely covered. And there's complete test coverage for everything. So every possible case that could happen, everything, it tests it all. So, and that took thousands upon thousands of lines to get that work. But in a running sense, if I do npm run, npm run dev. So what it's doing now is it's going to build the CSS files for the front end, and then it's going to run the project. And then if I go, where are we? If I go in a web browser, then it'll run everything. So now if we go to localhost, yeah, now it runs the project with the new lobby structure. So this is kind of what the whole like homepage looks like. We have a tutorial which we're actually planning to scrap and rebuild because it's kind of hard to understand how to play the game in this sense. But there's those like clean descriptions I was talking about. It explains how to play all the cards along with the expansion pack, and then me and my friends were all the other people that worked on it. And I'd like to note, like it wouldn't really be too possible without them helping. I mean, it's a big project and it's not a one-man team. So, yeah. But how that looks is, if you want to make a lobby, you just enter like this. It comes up with this nice pop-up that you can use, and then you kind of enter what your name is, and then you can pick an avatar. You join the lobby, and then now we're in, this is like the lobby page. So it has like one singular game room, and then if I make, see this thing is kind of smart in its sense. If I use another tab, and then go to the same, if I go to the same URL, it automatically knows that I'm the same player because it saves it in the storage of the browser. So it automatically knows that I'm the same person. So I have to go into another one. with that, and then yeah, we have dark mode now, which is very nice. But yes, so now we have two people playing over two different clients. If I go ahead and start the game, for the host, I'll ask them if they want to do something else. But this is kind of what it looks like. This doesn't look too nice in dark mode right now. We're working on getting dark mode cards. Right now, that's what we got. So for Madison and Radisson, you just play like so, and then this is what I've spent so much time doing, is just going back and forth, clicking these cards until you draw an exploding chicken. Now that player, if they don't play within the time limit, so if I don't play this and I select where I want to play it, I'll say on the top. And that's like the whole premise of the game, is now that I'm playing, I probably want to shuffle, but I'm just going to skip. And then this guy might want to see the future, so now you can see, oh shoot, there's an exploding chicken on top. And then you might reverse, and this guy might draw. And then it says who placed it, as long as it wasn't shuffled. So I'll just let, I don't know who's dying. Madison's dying. So I'll just let that ticker run out. But this is what was hard, is getting this to work. So if I refresh on either browser, it'll still work the same way. And then this is what it looks like at the end. So they're in this game page. In a couple seconds here, it'll just auto redirect them back to the lobby. And then this is for everyone. So you could have 100 games going simultaneously in the same space. It's just this lobby page would display all of that. So this goes back to the lobby, and then you can go again with the same thing. So yeah, there's a lot of stuff here, and we're getting an account system working, so people can log in and see what games they have played, as well as with defaults. So yeah, and then there's all these. That whole option right there. That's the power of the partition players function, that it can take all these options with how they want to be grouped and what their room size is, and automatically generate games for those players to play within. So it's pretty clean. But yeah. Any other questions on this? On anything? All right, cool. Yeah, we could play the game. I don't know how much time we have. 5? Because the only thing is we can't use this fancy lobby thing. So that means, that might not work, because only 5 people, or only up to 7 people can play right now. Because that's the issue, or why we made this in the first place, is the original one, which is running at chickens.rackerman.com. Looks very similar, but if I join a game, yeah, and this was released in last October, so it's a bit old. Yeah, it doesn't have as many options, but it works. It's just, you only can have up to 7 players up here. So yeah, I don't think playing a game would be feasible, but if you want to afterwards, it's definitely an option. Yeah, I don't know. We'll do Piazza Post or whatever later, but if you guys want to play. But yeah, I think that's it. Thank you all for joining. Fun. All right, cool.
Oh no, don't go away yet. All right, so how did it feel presented?
Well, it felt pretty good. You guys are like the first big audience I've talked to about this project before. But I love speaking in front of you guys, so it was fun.
So some of just the key takeaways. I'm going to keep you for like 2 more minutes, and then we'll end a little bit early because it's too beautiful outside to stay inside right now. So some of the key takeaways I got from listening to your presentation, I got a preview of it the other day, is one of the questions was how much documentation did you do at first, and you just went kind of out of your head.
Yep.
If you could go in a time machine and do this again, how much documentation would you have liked to do? And illustrating and drawing things out and ideation before you started, if you could do it over again.
Yeah, like definitely it sounds, especially with test cases, it's like really annoying to write those in your projects, I think. but documentation would have helped a lot. As well as with other people working on it, documentation is pretty key. Test cases you can work with, but
You should do the test
Yeah.
cases you develop. That's a bad message.
yeah.
So the other thing that I was noticing, and this is a common thing, is as the versions continued, you realized that your code needed to be more modular. That there was way too much, it was way too tightly coupled, which made changes really, really difficult, and you essentially had to rewrite it. So is that something that you consciously realized after you did it the first time and wanted to improve it?
Yeah, the reason was like I did want to make some type of test case, like to do anything on it, but you couldn't because the front end and the back end were so tightly woven together that you couldn't get anything to work. So after the fact, it was kind of like a thing you notice afterwards. But if you're just sitting there like typing code away, you don't really notice that.
Of course, if you had planned it out ahead of time.
Yes, exactly. But
So-
it got bigger than what we anticipated too.
Yeah.
So, or at least the code base did.
So this is kind of what, I've talked to you about how modularity is like a really desirable thing in code. You really don't want things to be tightly coupled. This is a really good example of it. First version, awesome, great project, but once it starts to scale, right, getting bigger, it just doesn't work, right? And as you want to make improvements, you want to do a lobby abstraction, you want to do some other things, you're just not going to be able to do it. And eventually, it'll scale so big that when you want to make a change, and if everything's tied together, you can't do it, because in the Ackerman dev company that's making these games, it just becomes too expensive to rewrite the whole thing. You can't do it, right, from a practical business standpoint. Two more things, and then I'll let you go. One, who remembers talking about model view controller in class? It's everywhere, everywhere. You are doing model view controller. You are actually implementing, in the games you've done in this class, a very simplified desktop version of this. This is MVC using web development, right? But you're still using sockets, you're still networking, you still have a separation between what the user sees and interacts with, the logic of your program, and then whatever data you're saving. You, in your projects, you've made schema, right? You had to figure out what persistent data do you need to keep track of. You did it as classes. This is a little different, but it's the same kind of idea. In this class, what we do is we do this, but we do it locally because then everyone can do it on their own laptop. And we really simplify it down. But the basics, the underpinnings of this, it's all what you've done all semester. It's the same thing. It's JavaScript instead of Java. It's web development instead of desktop development. But it's the same thing. Same thing, same ideas, same separation of duties, same thing. All right, one more round of applause for Asin. So I have to say, it's faculty interviewing season. So I've seen a lot of potential faculty members come in over this semester, and they come in and the teaching faculty, they will give a lecture, a guest lecture. And then the tenured faculty, they give a presentation of their research. This is very good. Very good. And I have to say, in some cases, better than some of the people who have come in here looking for jobs. And doing this kind of presentation, especially a technical one, it's really, really tricky to do. And just on your presentation, so when you had the cards, what the cards do, and then showed it in code, that was really good. Really good. I should incorporate that into some of my slides, and I'm going to steal it from you, but that was a really, really good idea.
Thank you.
All right, any final questions, comments? Go.
Would this be recorded and saved outside of class?
This is recorded. So it's in Echo 360. If you would like to see the recording and you are not part of the Blackboard course page where you can just go to it on your own, email me and I think I can send you the link to it. Is that a question? Okay. All right. As far as this class goes, next week we will have a lecture on Tuesday. You will have a quiz and a homework to do. You have your project to finish up. On Thursday of next week, we will just talk about your final exam. So come with questions. It will be cumulative. And we'll go over 2 questions that for some of you will actually be on your final exam. So watching next week's lecture on Thursday or showing up is a really good opportunity to maybe see 2 questions with the correct answers that might be on your exam. All right, everybody, have a great weekend. Go out and enjoy the day.
That was awesome.
Really, really good.
Thank you.
Really, really good.